All right, next up we're moving on to reduction of order. And so what we're going to do is we're just going to introduce the problem and its general approach, which is going to be to kind of use a substitution type thing. And we'll spend a lot of time on that general approach. And the thing I want to emphasize there is that you should not be using a formula to solve this type of problem. That approach and the reasoning behind it is sort of flexible and useful in other situations. Writing down the formula is not. And then after that, it'll probably take a while, so we'll have time for at least one specific example, but maybe not more than that. But sort of to build up to what we're doing, let's think about kind of the type of problem we've been discussing recently. So we started talking about nth order differential equations. And we learned that we can use superposition to find the general solution as y equal to c1y1 plus c2y2, so on and so forth down to cn as long as you have that those y1 through yn form what's called a fundamental solution set. And last section, you all would have learned that that just means that they're solutions and linearly independent, and that there are n of them. And that's how we're going to build solutions throughout this section. But we don't have a way yet to find those y1 and yn. In all the examples that you did, you were sort of given y1, y2, maybe even y3, and then asked to just check that they're a fundamental solution set. So we don't know how to find those functions. And today, we're going to discuss how to find one part of a fundamental solution set. And we're going to just be thinking about second order homogeneous differential equations. Which means they can be written like this. Y double prime plus some function of x times y prime plus some function of x times y equal to 0. So this is a second order differential equation. So we need to find y1, y2 to build our general solution, y equal to c1, y1 plus c2, y2. And so I'm going to outline what we're going to do, and then we'll actually work through it using like generic variables. So it's going to involve a little bit of algebra, and I want you to have a firm idea of what we're doing before we actually jump into it. So what we're going to do is for this type of problem, we're always going to assume that we're given one of the solutions. And then we're going to sort of make a special substitution where we say that y2, the solution that we're missing, is some function u of x times y1 of x. And we're going to just plug y2 into the ODE. So that's going to mean that we have to take y2 double prime, y2 prime, y2, and substitute in ODE. We'll cancel out y1 terms. The way we'll be able to do that is because they satisfy the ODE, so they'll just kind of drop out. So y1 double prime plus p y1 prime plus q y1 is going to be equal to 0, and we'll just sort of identify that quantity and then pull it out of the equation. And our entire goal here is to solve for u of x. And after we solve for u of x, we're going to know y2 equals u of x, y1 of x. And then that means that we've solved our problem. And can write our general solution, y equal to c1 y1 plus c2 y2. So that's what we're going to be doing. This part right here, those 3 steps are going to be the bulk of what we do, and a lot of it is algebraic manipulation right here, some calculus and product rules right there, so it can get a little bit overwhelming. But as long as you bear in mind that all we're doing is making a special substitution, which is an idea that you should be familiar with from exam 1, that special substitution, we're just trying to solve for u so that we know y2, so that we find our general solution. So in the next video, we'll see how that actually looks.